two events are independent when the occurrence of one event does not affect the probability of the occurrence of the other event. Okay? So two events are independent mathematically if I take the probability of B given A just happened and A has no effect on B, and therefore this is equal to the probability of just B happening itself. Okay? So this says A happened and it did not affect the chance of B happening. If that is the case, then the two events are independent of each other. One event does not affect the probability of the other event happening. Now this thing also works if I take the probability of A happening given B just happened, and this is the same as the probability of just A happening itself. Okay? So if those two things, either one of those two things are true, and then that shows us that A and B are independent. Now the opposite of being independent is dependent. Dependent is when two events are not independent. How about that? All right. So let's go back to the 2-card example. We draw a 7 and then you draw a jack. Are these two events independent of each other? Okay. What is the probability of drawing a 7? Right? The probability of drawing a 7 is equal to, well, how many 7s are in the deck? There's 4 7. There's a 7 of hearts, 7 of diamonds, 7 of clubs, and a 7 of spades, right? So there's 4 7s out of how many cards total? 52. Okay, 4 out of 52. Now, what's the probability of drawing a 7 given you drew, what's the probability of drawing a 7 given you drew a jack? Okay, given you drew a jack. So, I'm sorry, guys. I actually did this in the reverse order. So draw a 7 first, then draw a jack. So let's change this out for just a little bit. This is the probability of drawing a jack. Okay. Now there are still only 4 jacks, so 4 out of 52, right? But then here, what I'm asked to do, I want to find the probability of drawing a jack given I just drew a 7. So you drew your 7 first, and then you drew your jack, right? So what's the probability of drawing the jack given you just drew a 7? Well, if I pulled the 7 out and I didn't put it back, I drew it without replacement, then that means that there's only 51 cards left in the deck. But since it's a 7, it doesn't affect how many jacks were in the deck, so there's still 4 jacks. But guess what? This probability and this probability are not equal to each other. Therefore, these are dependent events. Thus, drawing the 7 first alters the chance of drawing the jack. Okay, alters the chance of drawing the jack. So jack and 7 are dependent events, since the probability of one is affected by the other one's occurrence. Okay, let's try this one. Flip a coin, okay, either heads or tails, and then roll a die, 1, 2, 3, 4, 5, 6. Okay? Find the probability of rolling a 2 given you flipped a heads. So how do I write probability of rolling a 2 given I flipped a heads? I write that as the probability of, that's how I interpret this first part, probability of rolling a 2. So rolling a 2 given that I flipped a heads. Okay? Now, does flipping a coin have any effect on rolling a 2? No, it does not. So this is literally equal to the probability of rolling a 2, which there's only 1 2 out of 6 total options when you roll the die. Okay? So flipping a coin does not change our chances of rolling a 2. Therefore, these events are independent. Okay, they are independent of each other.